Okay.
Okay.
Hello
Hello
everyone.
everyone.
Welcome
Welcome
to
to
week
week
10
10
of
of
problem
problem
solving
solving
session
session
for
for
NPTEL
NPTEL
course
course
problem
problem
solving through
solving through
programming in
programming in
C.
C.
And
And
so we
so we
have
have
two
two
parts in
parts
this
in this
session as
session as
always.
always.
First
First
is a
is a
quiz
quiz
session
session
where
where
you
you
have
have
some
some
multiple
multiple
choice
choice
questions
questions
and then
and then
followed
followed
by
by
a
a
few
few
programming
programming
questions.
questions.
Okay,
Okay.
so
So
this is
this
the
is the
first
first
question.
question.
The
The
question is
question is
asking the
asking the
output of
output
the
of
C
the C
program
program
given
given
below,
below,
and
and
I
I
will
will
I will
I
let
will
you
let
go
you
through
go
the
through the
program, and
program, and
then
then
there are
there are
options on
options
the
on the
right
right
hand
hand
side,
side,
A, B,
A, B,
C,
C,
D,
D,
and you
and
have
you
to
have to
tell me
tell me
which
which
option is
option is
correct.
correct.
Okay, sorry, I think uh, my screen must not be visible right now. Is it visible? I lost.
Yes, yes.
Okay. Okay.
Okay.
So
So
yeah,
yeah,
Shivani
Shivani
gave
gave
answer
answer
as
as
option
option
B.
B.
Okay.
Okay.
Would you
Would you
like to
like to
explain
explain
that
that
by
by
unmuting
unmuting
yourself?
yourself?
Any other
Any other
answers,
answers,
or
or
everyone
everyone
agrees
agrees
that
that
option
option
B
B
is
is
correct?
correct?
No other
No other
answer?
answer?
Mhm. Anyone
Anyone
wants to
wants to
explain why
explain why
option B
option
is
B is
correct?
correct?
Okay.
Okay.
So
So,
first we
first we
have
have
here a
here a
string,
string,
sorry,
str1,
str1, which is
which
a
is a
array
array
of
of
characters,
characters,
and it
and
is
it is
initialized
initialized
using
using
this
this
string
string
uh,
um,
syntax. So
syntax. So
basically you
basically,
have
you
these
have these
double
double
quotes, and
quotes, and
inside
inside
that you
that you
have a
have a
bunch of
bunch of
characters.
characters.
And then
And
the
then the
second one
second one
is
is
str2,
str2,
which is
which is
also an
also an
array of
array of
characters, and
characters,
this
and
is
this
how
is
you
how
have
you have
initialized
initialized
this
this
with
with
this
this
curly
curly
braces.
braces.
Now, in
Now,
the
in the
first
first
initialization,
initialization,
you
you
see that
see
there
that
are
there are
five
five
characters
characters
here,
here,
but what
but
is
what
not
is not
visible here
visible
is
here is
that
that
it
it
is
is
terminated with
terminated
a
with a
null
null
character.
character.
So
So
when we
when we
use these
use these
double
double
quotes,
quotes,
then
then
this
this
string,
string,
this
this
array of
array of
characters,
characters,
it
it
has
has
one more
one more
character at
character
the
at
end,
the end,
which is
which
the
is the
null
null
character.
character.
So
So
that's
that's
why
why
this
this
has
has
six
six
characters.
characters.
Okay,
Okay.
while in
While
the
in the
second
second
case
case,
it
it
is
is
how
how
many
many
characters are
characters
there.
are
We
there?
have
We
to
have to
count
count
1 2
1, 2,
3
3,
4
4,
5
5,
6
6,
7
7,
8
8,
9
9,
10
10,
11.
11.
There are
There are
11
11
characters
characters
here.
here.
So
So
n1
n1
in integer
integer
of
of
int
int
n1,
n1,
this is
this is
counting the
counting the
number of
number of
characters
characters
in the
in the
string
string
1,
1,
which is
which
you're
is you're
saying, okay,
saying,
what
okay,
is
what is
size
size
of
of
str1?
str1?
So
So
size of
size of
str1
str1
will
will
be
be
6,
6,
because each character takes 1 byte, so it is 6 bytes. Okay, then you divide it by the size of first element, which is the first character, str0, and the size of a character is 1 byte, so 6 byte divided by 1 byte will be 6. Okay, so n1 is 6, and similarly n2 is equal to size of str2, where str2 size of this str2 is 11 bytes divided by size of str2 0, that is the 0th element, which is one character, so 1 byte, so it is n2 is 11 bytes divided by 1 byte, that is 11. And then when you print n1 and n2, it will be 6 and 11. That is option B. Is there any question? Okay, if not, let's move to the problem 2. Here you have to fill in this blank. Okay, in dash, the search starts at the beginning of the list and checks every element in the list. So there are 4 options. A is linear search, B is binary search, C is hash search, and D is binary tree search. So in which of the following the search starts at the beginning of the list and checks every element in the list? Yes, A option is correct. So Shiva gave the answer that linear search. Yes, it is linear search. And it's the same as what it is written here, but I will still just go over to the whiteboard, which is taking some time to open. Okay, so here if you have, so what is linear search? Linear search means okay, I don't know what's wrong with my whiteboard today. What is wrong? 1 second. Okay. Not able to figure out how to write today. What's wrong? I'll just do something else. Okay, so I'll just explain here in this. So in linear search, if you are given your input is actually an array of elements. So I'll just say that, okay, it is, let's say, an array of integers. example would be say 10, 20, 6, 45, 70, or something like that. Okay, and your goal is to find a given element in this array of integers or a list of integers. And example could be, say you are asked to find 20. Then what you will do is that you go to every element in the list. Like first you will look at 10 and you will compare it with 20, that whether these two elements are equal or not. So they are not equal, so you will move to the next element and you will compare 20 with the search key, and here it matches, so you can declare okay, 20 is at index 1. Then other search key can be say 78. So then you will first compare with 10, then 20, then 6, then 45, and then 70. But none of them are equal to 78. So in the end, you can declare that 78 is not present in the list of elements. So that's linear search, that you look at each and every element one by one in the list. You can do that search in any order you want, but you have to look at every element to find whether the given search key is present in the array or list of elements or not. Okay, that's your linear search. Now moving on to next problem, which is what is the worst case time complexity of bubble sort? Do you guys know bubble sort? Option D. Yeah, option D is correct. It is order n square. Do you want me to explain bubble sort, or I can assume you already know? Okay, I'll explain. One second. Okay. This was your linear search. Bubble sort. Okay, we are looking at bubble sort. So let's take again we have the same input. Your input is same in bubble sort. Okay, it is again a array of integers or array of some elements. Here I'm taking integers. Example is this 10, 26, 45, 70, and your goal is to sort them in some order, say ascending order. Okay, and so your output in this for this given input will be 6, 10, 20, 45, 70. Now how do you do that? So one of the algorithms to do that is bubble sort. Okay, now how does bubble sort work? So in bubble sort, in the first pass of bubble sort, this is your input. Okay, so this is your input initially. So in the first pass, what are you going to do is you will look at the first two elements and you will compare them. If they are in correct order, that is the ascending order, then you will not do anything. Okay, so here you don't need to do anything. So after first step, your array will look same as before. Then in the next step, I'll just mark them bold that these were compared. Then in the next step, you will take the next two elements, 20 and 6, and then you are going to compare these two. Now, when you compare these two, you will find that 6 is smaller than 20, so it should come before 20. So you will swap these two, okay? So this will be 10, 6, 20, sorry, 10, 6, 20, 45, 70. This will be your array after the second step. Now you are going to take the next two elements, 20 and 45. Okay, you take the first and second, then second and third, then third and fourth. So you're going to take adjacent elements every time and you're going to compare them. Okay, so 20 and 45 are in correct order, so no need to do anything. So your array will be same as before. I'll just copy it here, and then here 45 and 70 will be compared. Okay, and again you will see that they are in right order, so no need to do anything. So this will be your array after this step. Now the question is, like, is this sorted now? Is the output like 10, 6, 20, 45, 70? It is still not sorted, right? Because 10 and 6, as you can see, are not in order. So this was first pass of bubble sort, okay? This was first pass. Then in the second pass, you're going to take the output of the first pass, okay? And now again you will do the same, that you will take the first two elements here and compare these two. So 10 and 6, they are not in order here, so you will swap both of them. Then next two elements, 10 and 20, will be compared, but they are already in order, so no need to do anything. No swap will happen here. Then in the third step, you are going to take 20, 40, compare them. Still no need to swap. Can you please mute yourself? Okay. So 6. So 20, 40 will be compared. They are already in order, so no need to do anything. 10, 20, 45, 70. Then 45 and 70 will be compared. And after that, still they are in right order, like 45 is coming at before 70, right? So this will be your output after the second pass. Now in the third pass, I'm going to just remove these lines so that you can see clearly. In the third pass, you will take the output of the second pass, okay? So you will complete here. Now you will compare first 6 and 10. They are in order, no need to do anything. Then 10 and 20, they are in order, no need to do anything. Then 20, 45 are in order, and 45, 70 are order. So everything is in order and there was no swap. So when there is no swap in a pass, then you can terminate the bubble sort, okay? The bubble sort, you can just say, okay, now the array is sorted and there is no need to do further anything. So that is your bubble sort, okay? You take the adjacent elements. If they are not in order, then you swap. And you do this n times. Like in worst case, you will have to do this n times. Okay, like n passes, and in every pass you just take the adjacent elements and compare and swap if required. So that is your bubble sort. So that's why the complexity, because in every pass you are comparing order of n times, like n minus 1 comparisons are needed, because there are n, if there are n elements, then n minus 1 comparison, and then there can be up to, like, in terms of order, like asymptotically, there can be up to order of n passes, and in therefore the time complexity is order of n square. That is, there are two nested for loops are required in implementation of this bubble sort. Okay, so that was the question. It was asking what is the worst case complexity of bubble sort. So in the worst case, it is order n square. While in the best case, when your array is already sorted, like if this were your input 6, 10, 20, 45, 70, then in the first pass itself, you will compare the elements with each other, and there'll be no swaps, and you can just in one pass you can declare, okay, the array is sorted, and that will require order n complexity. So in best case, the time complexity when the array is already sorted, bubble sort takes order n time, and in the worst case, it takes order n square time. Is that clear? Okay, let's move to the next question. This is also on bubble sort. So it is asking, what is the maximum number of comparisons that can occur when a bubble sort is implemented? Assume there are n elements in the array. Okay, any answers? Okay, let's look at it on whiteboard. Option B. Okay. Would you like to explain, Shivani? Okay. So you are asked how many comparisons, maximum number of comparisons. In bubble sort. So we just looked at in the last last question that how does bubble sort work. Okay, now let us look at it again. And so your example was 10, 6, 20. Example was a little different. I'll just have to Okay, I'll make a new example. Let's say 70, 6, 10, 5, 4. Okay, let's say if this is your array, input array that you want to sort, then how will bubble sort work? Okay, we will write we'll do the first pass. In the first pass means we will compare the adjacent elements. If they are not in order, in ascending order, then we will swap them. Okay, so first we will compare 7 and 6. So when we compare them, they are not in order, so we will swap. So this will be 670. Next, as it is, so then we will compare 70 and 10. So it will become 6, 10, 75, 4. Next, we are going to compare 70 and 5. So then this becomes 6, 10, 5, 70, 4. Okay. Next, we are going to compare 5 and 70. Sorry, we have already compared 5 and 70. Next, we are going to compare 70 and 4. So this will be 6, 10, 5, 4, 70. Now, if you will look at this, you will see that your 70 was earlier at first position. But when you did first pass, then 70 reached the last position because 70 is the largest element in this given list of elements. Okay, it's the largest integer. So, and why did it happen? Because whenever you are going to compare 70, you compared it with 6, it got swapped. Then it got swapped with this, then 10, then it got swapped with 5, then it got swapped with 4. So an element which is the largest element in the first pass, it reached at the last position. So it is now at its correct position, right? 70 is now at its correct position because it is the last. Now, if we do the second pass, so now what is the second largest element? It is 10. So now let's see if 10 comes to its correct position or not when we do the second pass. Okay, so here let's do the second pass on this side. 6, 10, 5, 4, 70.
ఇక మనకు మన పిల్లలకు విలువ లేకుండా ఇట్లా కష్టపడుతున్నాం. మన పొలం విలువ ఉంటే.
Oh, am I not audible? Hello. 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 Am I audible now? Hello. Okay, thanks. And please mute yourself if you're not speaking. Okay. I hope my screen is visible. Is my screen visible? Can you see this list of array written on the screen? Can you see the list of array? Hello. Am I audible now?
Yes, ma'am.
Can you see the screen? Okay. Okay, if I am not audible or if the screen is not visible, then you can unmute yourself and let me know, because sometimes I'm not looking at the chat window, okay, when I'm explaining on the whiteboard. So I'll just explain it quickly what I did here, because I'm not sure if I lost my audio before that or after. So this is your initial array 76, 10, 5, 4, and this is your first pass. Okay, so this is your first pass of bubble sort. Okay, so this is your initial array 76, 10, 5, 4. Then in the first pass, what you're going to do is you're going to look at each pair of each adjacent pair of integers, and you're going to compare them, and then you will swap if they're not in order. So 70 compared with 6, not in order, so we swap 6 with 70. Then you compare the next two elements 70 and 10. They are also not in order, so you swap 10 and with 70. Then you looked at 5 and 70. They are also not in order, so swap 5 with 70. Then you looked at 74 and not in order, so you swap them, and now 4 come before 70. So after the first pass, as you can see here, 70 was initially at first position, but it moved one step after each. So it moved right hand side at each step, as you can see on the diagonal, and finally it reached at the last position. Okay, and how many comparisons happened? There were 5 elements. Okay, 5 elements, and 1, 2, 3, 4. 4 comparisons happen. So if we generalize this, then if there are n elements, then n minus 1 comparisons will be required. Okay, but in this n minus 1 comparisons, your element, which is the largest element, it doesn't matter where it is located in this array, your largest element after the n minus 1 comparisons will reach at the last position, which is its correct position, because largest element should be at the last position in the array. Okay, now what will happen in the next pass? So for the next pass, this is your array 6, 10, 5, 4, 70, which I've written over here. Okay, 6, 10, 5, 4, 70. Now we will again compare and swap when required. So 6 compared with 10. So now in this pass, before I do this, so this 70 is at its right position, right? And this 10 is the second largest element, so it should come at position of 4, right? So that's what we expect. So let's compare 6 with 10. They are right in order. They are in order, so we don't need to do anything. So 6, 10, 5, 4, 70. Then we will compare 10 with 5. Okay. They are not in order, so swap. So 6, 5, 10, 4, 70. Then you will compare 10 with 4. Okay. So 6, 5, 4, 10, 70. Now, do you need to compare 10 with 70? No need, because you already know that in the first pass, the largest element reached at its correct location. So you no need to compare it with 70. It's already in its right position. It is greater than 10. That is like known. Okay. In the first pass, the last element is sorted. You don't need to compare with that. In the second pass, your next element 10, which is the second largest, reached at its correct position. That is the second last in the array. And how many comparisons were needed? You needed 3 comparisons here. 3 comparisons. In this, you needed how many? In the first pass, you needed how many? 4 comparisons. So in the first pass, there were n minus 1 comparisons. And after n minus 1 comparisons, your largest element reached at the last position, which is the correct position. In the second pass, you did n minus 2 comparisons, okay? N minus 2 comparisons, and your second last element reached at the correct position. That's why it is called a bubble sort, because it's like bubbling the in every pass it will bubble up, like it is bubbling the largest element at its correct position in every pass. In the first pass it bubbled, like it separated the 70, like largest element which was 70, to its correct position. In the second pass the largest element was 10, and it moved it to its correct position, which was second last. Okay, now if you will do the third pass, okay, let's do the third pass here. You have sorry, 6 5 4 10 70. This is your array. Then no need to like you don't need to touch 70, 10 and 70. They are in order, okay? So they are in order, and so you just compare. First you will compare 6 with 5. They are not in order, so swap. Okay. Then you will compare 6 and 4. They are also not in order, so you will swap. So now if you will again see that the third last element now reached at its correct position after the third pass. This was your third pass. And how many comparisons were needed? 2 comparisons, which is n minus 3 comparisons. Like in terms of n, if you have to write, if there are n elements, then it is n minus 3 comparisons. So what does this, so what did we learn from this example? That in the first pass, the largest element reached at its correct position required n minus 1 comparison. Second pass, the second largest reached at its correct position required n minus 2 comparisons. In the third pass, third largest reached at its correct position required n minus 3 comparisons. So finally, so this is the series which comes, like you will do n minus 1 comparisons, then to correctly place the largest element, then correctly place the second largest using n minus 2 comparisons plus n minus 3, and you will do it until only the first 2 elements are not sorted, and that will require 1 comparison. Like you just need to check the first 2 elements, that requires 1 comparison. So this is your number of comparisons that are required when your array is, like this is the worst case. Okay, this is the worst case number of comparisons that will be required in bubble sort. So this is your series, and if you know already that, I'll just write it here. If you know already that 1 plus the series sum for 1 plus 2 plus 3 plus dot plus n is equal to n into n plus 1 divided by 2. So using this, let's call it 1. Using 1, the sum series of the series n minus 1, that will be n into n minus 1 divided by 2 comparisons. So this is the maximum number of comparisons that are required by bubble sort in the worst case, when your array is is in such a manner that you will have to you require all of these comparisons. Okay, this is the worst case. So let's look at the options now. What is the maximum number of comparisons that can occur when a bubble sort is implemented? And assume there are n elements in the array. So second option is n into n minus 1 divided by 2. So B is your correct option. Is there any doubt in the explanation or the question? Okay. I am assuming that there is no doubt. So option B is correct here. Let's move on to the next question, and it is also related to bubble sort, and I really want you to try this. And this is like you have to do the first pass here. Okay, what are the correct intermediate steps of the following data set which when it is being sorted with the bubble sort? This is your given array 74182, and if you do first pass on this array, then you have to tell that which will be the intermediate steps. Okay, you have these four options. Any answer? D is not correct. Can you try again? You have to do only first pass, not the entire bubble sort. Just the first pass. Okay, I think entire bubble sort is here happening here, but D was not correct. Option B is correct. Okay, I'll explain it on the whiteboard. Okay, this is your given input 74182. Just write this. Okay. And so first you are going to compare 7 with 4, and they are not in order, so swap. Okay. 4 7 1 8 2. Then you're going to compare 7 with 1, not in order, so 4 1 7 8 2. Then you will compare 7 with 8. They are in order, so no need to do anything. Then you're going to compare 8 with 2. They're not in order, so you swap them. Okay, next you're going to just write here. Okay, so this like finished your first pass. Now your second pass is starting from here 4 1 7 2 8. So you're going to take first two elements and check, compare them. They're not in order, so swap 1 4 7 2, 8. Then you compare 7 and 4, 4 and 7. They're in order, no need to do anything. Then you will compare 7 and 2. They're not in order, so swap. Now this finished. Then you'll compare 7 with 8. They're in order. No need to even compare them because you already know that 8 was in order. Now 7 came in order. Okay. So this is your second pass. Now third pass. When you do it here, 1, 4, 2, 7, 8. Okay. First you're going to compare 1 with 4. They are in order, so no swapping required. Then you compare 4 with 2. They are not in order, so you will swap. 2, 4, 7, 8. This is your third pass. And then you come here. 1, 2, 4, 7, 8. Okay, you will compare the first two elements here, but they are in order. So this is at your out. This is sorted. Okay, so this is these were the intermediate steps, and option B was correct. Any doubts?
No doubt, ma'am.
Okay, thanks. Okay, which of the following statement is correct for the two arrays with respect to A and B? So A and B, these are your two array. So array A is an array of pointers, and array B is a pointer to an array. Okay, so A is an array of pointers, B is a pointer to an array, and you are given these two declarations of X and Y. Okay, and you are asked if X is an array of pointers or pointer to an array, and same Y is a pointer to an array or an array of pointer. Like you have four options, where first option is saying X is array of pointer, Y is pointer to an array. Second is X is array of pointers, Y is pointer of array of pointers. So you have these four options, and you have to tell what is X and Y. Okay. So I got one answer. Okay. Any other answers? Okay, so the correct answer is option B. Both of these are like declarations. Both of these declarations are array of pointers. They're not pointer to an array, they are array of pointers. So X, like here, X, how do you read this? Like X is an array, and this is the data type it is storing. So it is storing integer pointers to an integer. It's an array storing integer pointers. Similarly, Y is an array storing integer pointers. Both of these are array of pointers. How do you declare a pointer to an array? You just write int star p, that is pointer to a integer, and you just assign it with the address of the array, which is the name of the array. Okay. So coming here, so your pointer to array. How do you declare a pointer to an array? So if your array is, say, int arr 5, if this is your array of, we'll just write it here, maybe a. If a is your array of integers, then if you have to write a pointer to an array, so that means you need to write a pointer to the first element of the array, that is like pointer to an array. So you just write int star p is equal to a. What is a? A is the address of the array. Okay, it's the address, the name of an array is its address. It's the address of the first element and also the address of the array. So this is how you declare a pointer to an array. It's basically a pointer to an integer, but the elements in the array are integers. So p here is pointing to the first element in the array or the address, base address of the array, and hence p is a pointer to an array. And array of pointers, you have to, so you have already seen that you have to write, if you have to store integer pointers, then int star, that is what you want to store, and you can call it, say, b. So b is the name and 5. So now b is an array of integer pointers. So b is an array storing pointers to integers. You can put parentheses here, but that is same. Like that doesn't change. Sorry, this is square bracket and that's parentheses. These are same array of pointers. Okay. Is there any question? Okay, moving on to problem 7. Find the output of the following program. So here ptr is a pointer to an integer. A is an integer assigned value 5. Now you have to look at the next statements and tell me that what will be the output of this print statement. Yeah, that's right. Would you like to explain? Okay, fine. Anybody else has any other answer or the same answer? Like you can write in the chat box. Right, your explanation is correct that the pointer changes the value at its address. Yep. Okay. Okay, I'll explain it on the whiteboard. Just copied it. Okay, this is your program. Okay. And here, okay, first is a pointer to an integer. Okay, ptr. So let's just write this here. This is ptr. Okay. And this is your variable a, and a has value 5. What are you going? Then this was your first line. Okay. In the second line here, you are storing the address of a in PTR. So if address of a is, let's say, 1000. Okay. Let's say the address is 1000. Like this location, this is your a variable. Okay. So address is 1000. So you're going to store that in PTR. 1000. This is your second statement. The third one is star PTR is equal to star PTR minus 3. So what is star PTR? So that means you are dereferencing the pointer. What does dereferencing means? Means what is the value at the address stored in this pointer? What is the value at the address? So what is the value at the address stored in this pointer variable, which is what is the value at 1000 address? So that is 5. Okay. So you're saying, okay, value at this address minus 3, which is 5 minus 3. So it is 5 minus 3, which is 2. Now you have to store that value. That is, you have to assign that value to value at address 1000. So you go and rewrite, like change the value at address 1000 equal to this value. So you're going to go here, change it to 2. Okay. This is your line number 3. In next statement, printf statement, you are here saying, okay, what is value at PTR? Excuse me, line. What is the value at PTR? Sorry, what is the value at the address stored in this variable like PTR? So the values at 1000. Value at 1000 is 2. So you're going to print here 2. Then what is the value of variable a? That is also 2, which was changed from 5 to 2. So 2. So this will be your output 2, 2. So here when you did star PTR, you actually changed the value at address 1000. Any doubt? Okay, next question is, what will be the output of this program? You have an A is an array of integers. This is how you have initialized this. It has very like say integers 10, 12, 6, 7, 2. Then I is an integer, P is a pointer to an integer, and then you have to just look at the next statements and tell which is the correct options. So correct option. Option D. 2, 7, 6, 12, 10. Yeah, option is correct. Oh yeah, right. Option D is correct, I think. Okay, I'll just quickly then explain this. So this is your program statements. A is an array of integers, I is integer, P is a pointer to an integer. So P is a pointer to integer. Here we are assigning some value to it, okay? We are assigning some, what is A? A is the name of the array, which is the base address of the array. So it is the base address of the array, or the address of the first element, zeroth element. Okay, then you are doing here pointer arithmetic. So A is also a pointer to a integer, because A is the name of the array. So A is the type of the this A pointer is integer here. Okay, if it were a character array, then A would be type of, A would be a pointer to character. But here A is pointer to an integer. Why is that important? It is important because that affects how arithmetic operation works. Arithmetic operation on pointers is different. Like when you say +4, it will actually be +4 according to the type of pointer. Okay, if it's an integer pointer, then it will add, like say if one integer is 4 bytes, then it will add 4 bytes for each increment. Okay, so here it is going to add. I'm just assuming assumption is here. What I'm assuming is int is 4 bytes. Okay, so then it will add each increment will add 4 bytes. So initially this is A, it is pointing here. When you will say A plus 1, it will point here. When you say A plus 2, it will point here. A plus 3 will point here. And A plus 4 will point here. Okay? So when you say A plus 4, this is where you are pointing. This is the address of the last element, which you are storing in P. So what does P has? P has the address of the last element. That is 2. Okay. Now you are using this for loop to print something. Now what is this? What is being printed? You're going, so the loop starts from I is equal to 0. A condition is I is less than 5, and on every loop iteration I is incremented by 1. So when the loop will start here, okay, loop will start here, I is initialized to 0, then you will go inside the loop, and here you use your like what is being printed. This is the argument. So it is P, and then you have square brackets minus I. So P is your pointer to an integer, and your I is 0. So what is this in first? So it will be P plus minus 0, which is like P. And it's actually the value at this location. It's the value at P minus I. Okay, so value at P. So value at P is 2. So it will print here 2. Then in the next iteration, I will be incremented. I will now become 1. So you will check the condition. 1 is less than 5. You come back. Now P minus 1. The value at P minus 1. That is going to be printed. Now again, P is a pointer to an integer. Okay. So this was your P. This is your P minus 1. Pointer arithmetic. That when you say minus 1, it is actually decrementing by 4 bytes. Okay. So P minus 1 is pointing to 7. So value at P minus 1 is 7. So it will print here 7. Then in the next loop, it will go on like this. Every time you will increment I, and you are printing P minus I. Okay, so P minus 2 will be printed, then p value at p minus 3 will be printed, and then value at p minus 4 will be printed. So basically the array is going to be printed in the reverse order. So output will be, your output will be 2 7 6 10, sorry, 2 7 6 12 10. So this is your output. That is the array in reverse order. Is there any doubt? Okay, now let's go to okay, we have here one programming question. So it is, write a program to calculate the sum of a given series. So this is your series. 1 plus 1 by 2 to power 2 plus 1 by 2 to power, sorry, 3 to power 3 plus 1 by 4 to power 4, and so on till 1 divided by n to power n. So your input will be one integer, which is n, and you have to output the sum of this series. So if n is 2, then your answer will be the sum of 1 plus 1 upon 2 to power 2. So like how will you do this? Like this is a programming question, so I want you to think about it. Like how will you do? How will you program this? And if you have any ideas, then you can either unmute yourself and tell me. You can write, or you can write them in the chat box. And after a few minutes, I'll discuss the program. Is the question clear? Okay, let's look at the program. Yeah, so this is like a question. So if you're given input as 5, so that will be, that is you're asked what is 1 plus 1 divided by 2 to power 2 plus 1 divided by 3 to power 3 plus 1 divided by 4 to power 4 plus 1 divided by 5 to power 5. What is this value? That's what you have to compute, and this is your output, that the sum of the series is 1.29 something. Okay. So let's look at the program. So since you have to compute powers of numbers here, so we can use one library for that. That is the maths.h library. You are going to use the POW function, which is defined in this library to calculate powers of numbers. Okay. Then this is your main function. Your program will start executing from main. First you declare here an integer n, which is your, like you are given, this is your n for which, like you have to compute the series up to n to power n, right? Then your result, since your result is in some decimal value, so you are going to declare it like a double. It's not an integer, it has to be a double. Then you're calling here a function series sum, and you're giving it as an argument n, and it is giving you back some value which you're storing it in result. Okay, so let's look at series sum function, where argument is integer and the return value is double. So here you're declaring I, which is a variable of type integer. Then you're declaring here variable sum, initialized to value 0, and it is of type double. And then you also have one other variable element. Okay. Now what you are doing here, that you have for loop starting from 1 till n, because that's what your series is, right? Your series, you need to compute each term in the series. Like you have to compute 1, which is obvious, but then you have to compute 1 upon 2 to power 2, then 1 upon 3 to power 3, 1 upon 4 to power 4, up to 1 upon n to power n. So to compute each turn, you need one loop iteration. You have one loop iteration. Okay. So each term is being computed in one loop iteration, and that term here is stored in this variable element. Okay, that is one element of the series is equal to 1 upon power of I comma I. If I is 1, then it is 1 upon 1 to power 1. If I is 2, then it is 1 upon 2 to power 2. I is 3, 1 upon 3 to power 3. That's what you want to compute in each iteration, right? So you compute the element in that iteration, and then you sum it up with the current sum. So sum is your current sum, which is initially 0. Then the first iteration you're going to add with sum 0 plus 1 upon 1 to power 1. Then you will go back to the for loop. Here I will be incremented to 2. Then I is 2 is less than n, say n is 5. So you will come back here. Then element now is 1 upon 2 to power 2. Power 2 comma 2. Okay, so that will be 1 upon 2 to power 2. That value you are going to add with sum. Now current sum was 1, so 1 plus some value. So this is how this for loop will run, computing each term and adding it with the current sum, like rolling sum, and then in the end you are going to return this sum value. That sum value is now here stored in this result variable of type double, and you are then printing this here. Now here %.6f. So f is used to print the floating point numbers, that is this decimal numbers, and 6 represents that you want to print up to 6 decimal digits. So digits after like 6 digits after the decimal points. So this was your, and this is a function declaration. Okay, you have defined the function here, but you have used the function in main, so you have to declare it before main. Either you can move the entire function body before main, or you can just write a declaration of the function before main, and you can define the function body afterwards. So is there any question in the program? Is it clear? Okay, let's look at the next one. So you have to write a program to express a given integer as a sum of two prime numbers. Now what does that mean? So let's look at an example. So what it is saying, okay, for example, if the number is 10, then you can represent 10 as sum of 3 plus 7, and 3 and 7 both are prime numbers. Or you can write it as 5 plus 5, where 5 is prime number. So you will be given an integer like 10, and you have to output two prime numbers which add up to this given integer. Okay. Next example is like 18. Okay, you have to output all of those prime numbers which add up to this, like 18. So 18 can be written as 5 plus 13, where both 5 and 13 are prime, or 7 plus 11. Okay, then 13 is 2 plus 11, and 7 is 2 plus 7. And if you are given 11, then 11 is actually a prime number itself, and now it cannot be expressed as sum of two prime numbers, which is not true for all prime numbers. Like 7 is also prime, but it is representable as two sum of two prime numbers, but 11 is not. So you can just output that this number cannot be expressed as the sum of two prime numbers. Now, first of all, do you know what is a prime number? Like, what is a prime number? You can write in chat. You can write that in chat box. So number is prime if it is divisible only by itself and 1. Okay, it has only two divisors, like itself, the number itself, and 1. So for example, 3 is divisible only by 3 and 1. It is not divisible by any other number. 7 is divisible only by 1 and 7. If you try to divide it by any other number, then it is not completely divisible. There will be some remainder. So a prime number is one which is divisible only by itself and 1. So examples of prime numbers are 1, 2, 3, 5, 7, and I think 11, 13, and so on. Okay, so these are your prime numbers. Now, I'll give you some time so that you can think about like how will you find the set of prime numbers which will add up to that given number. Is the question clear?
Yes, ma'am.
Okay. Is anything coming to your mind, like how can you solve this? You don't have to think of the program itself, like how will you program it, but just an approach, like how can you solve this problem. Like if you're given this problem, not you don't have to write a C program directly, just how can you solve this. Like if you have given 10, your input is 10. I'm just giving you number 10, and I want you to tell the pair of numbers which are prime and add up to 10. Now how will you find that? How do you find that 3, 7, 5, 5 are answers to this? Okay, let's look at this in the whiteboard. Okay. So let's look at 10. Okay. Example of 10. You have to your input is 10. That is, you have to find pair of numbers which add up to 10 and they are prime. Okay. So here, what are we going to do? We are going to start from 1. Okay, let's assume. So let's say number 1, which I'm going to represent as n1, is 1. Or maybe I'll use AB. Okay, AB. So A is 1. Now what can B be? So your condition is that A plus B should be 10. So what is B? So B is 10 minus A, which is, now what do you need to do? Wait, 1 second. So there are two numbers, A and B. These are your answers. You don't know what is A and what is B. Okay. So if you assume that you have some value for A, then what can B be? B is your number minus A, right? And you have to ensure that both A and 10 minus A are prime numbers. So from where can you start A? So you can start A from 1. Like A is 1, then B is 10 minus 1, which is 9. Now check whether A and B both are prime or not. Now A is prime, but B is not, because 9 is divisible by 3. Okay, so it's not a prime number. Then you will increment A. Now A is 2, which is prime. Now B will be 10 minus 2, 8. Now 8 is divisible by 2, so it is also not prime. Now A is 3, B is 7. Now 3 is prime, 7 is also prime. So this is your one answer. So the answer is 3, 7 is your answer. Okay. Now A is again, you can increment it to 4. B will be now. But you don't need to check because A is 4. 4 is not prime. 4 is divisible by 2. So no need to check. Okay. Now A is 5. Which is prime. B will be 10 minus 5, 5, which is also prime. So this is also your answer, 5, 5. Now you can increment A again and it will become 6. But if you will notice that you have already checked this here. If A is 6, B will be 4. So you have already counted that. Okay. So you need not check after 5. That is, you will check from 1 till n by 2. You will check from 1 till n by 2, and A will be from 1 to n by 2. B will be from like the number minus A. Okay, these are your options, and in these options you have to check where which options have both A and B as prime. So is this approach clear? Like is it clear that is the question clear, and is the is the solution also clear? Your input is a number, say here 10. You have to output two numbers, A and B, which will add up to your given number, and A and B both should be prime numbers. So since both of them add up to your given number, so if A is some number, then B has to be the number itself minus A. So you have to ensure that both A and 10 minus A are prime numbers. Okay. So what you did that, okay, let's assume A is 1, then B will be 10 minus 1, 9. And you check that both are prime or not. Here 9 is not prime. So you move next number, you increment A, and A is now 2. So B is 8, 8 is not prime. So this can't be an answer. Then increment A again, A is 3, B is 7. So they are both prime. So this is an answer. Then A is 4, B is 6. Both are not prime. Then A is 5 and B is also 5. So they are both primes, and hence this is your answer. 2. So two answers are there, 3, 7, 5, 5. Now I want you to try the next whatever test case we have. We have like let's say 7. So I want you to try 7 on your own, and so that the approach also becomes a little clear in your clear to you. Where did I write? Okay, if your input is 7, then what will be A and B values? Can you try in this same manner and tell me the answer in the chat box? Then we will look at the program. Any answers? If your input is 7, then which you have to tell the pair of numbers which are prime and add up to 7. Any answers? Is the approach not clear? You can tell me in the chat box and try to explain again. And if it is clear, then I think you can give the answer. It's simple. No answer? Is this not clear? Is the question not clear, or the approach not clear? Like what is happening? Okay, I'll explain. So input is 7. So you have to output numbers which are prime and add up to 7. So I think it is quite obvious, and that both the numbers has to be smaller than 7, right? If they have to add up to 7, they can't, one number can't be 7, 8 or anything, because the other number needs to be a non-negative number, and in fact a known negative and non-zero number. So both the numbers are smaller than the given number, and both the numbers add up to 7, and both the numbers need to be prime. Okay, so here if A is 1, if the first number is 1, then B is 7 minus 1, which is 6. Now 6 is not prime, because 6 is divisible by 2, which is 3. 6 is also divisible by 3, and it will give 2. So 6 is not prime. So this can't be an answer. Now A is 2, then B is 7 minus 1. Sorry, 7 minus 2, which is 5. So now A2 is prime, 5 is also prime, because they are divisible only by itself and 1. 1 is, like, every number is divisible by 1. Okay, that's not even need to check, but there was divisible only by itself. Okay, so this is an answer, 2 comma 5. Then A is 3, B is 7 minus 3, which is 4. Now this is not prime. So now you don't need to check further, because you need to check only from 1 till n by 2. So n by 2, 7 by 2 is like it's 2 point, sorry, 3.5, right? So you will check only up to 3. That is n by 2. So then your answer is only one option, like you have only this answer 2,5. Now let's look at the program. If there is any question, then you can just let me know. Does anyone have any question, any other comments? Okay, if not, let's just look at the program. Okay, so since you have to look at every number from 1 to up to n by, from 1 till n by 2, right? You will need one for loop, and inside that for loop you are going to check whether the number a and b are both prime or not. And so this is your program. This you have int main. Okay, this is your main function. First you have here n. N is a variable. It is the integer number which you have taken from the test case. Okay, then here you have the for loop where you are checking from 2 to up to n by 2. Okay, and on every iteration you are incrementing by 1. Then inside this for loop you are going to check prime for I and n minus I. Okay, the same, it's the same that what I just explained. You're going to check if I is prime. If I is prime, then you're going to check if n minus I is also prime. If both are prime, then you're going to print the values, that is n, I and n minus I. Otherwise, you don't need to do anything. You can just go and increment I and then check for I and n minus I. Now let's look at the check prime function. So check prime function takes as argument n, like some integer, and it outputs an integer. Now it is taking a variable here which is prime. Is prime is set to 1. So 1 will indicate whether this is a prime number or not, and value 0 will indicate that this is, value 1 will indicate that this is a prime number, and value 1 will indicate that this is not prime. So how do you find a number is prime or not? So for that, you are going to check divisibility of this number n with every number from 2 till n by 2. Okay, so again you're going to have this for loop I equal to 2 till I is less than n by 2, and on every iteration you're incrementing I by 1. And inside every for loop iteration you are dividing, you're using this modulo operator to check the remainder of this division, that is n modulo I. Like first iteration will be n modulo 2. If this is equal 0, that means this number is divisible by 2. If this number is divisible by 2, then this is not a prime number. So you will set this to 0, means false, that this number is not prime. So if this number n is divisible by any number from 2 to n by 2, then this is not a prime number. So if this condition becomes true any time, then you will just set is prime to 0, and you can just break out of the for loop, because you found a divisor of n which is not 1 or itself. You found some number which completely divides n, and it is not 1 and it is not n. Okay, so then you can just return is prime value. So initially you initialize this to 1, that is true, that okay, this number is prime, you're saying. But if you find any divisor, then you will make it 0, say that will indicate that this is not prime, and you are returning that value here. Okay, and this check prime function you're calling here with different values of I and n minus I to check whether this combination, both of the numbers are prime or not. So this was your program, and let's look at the next set. So next question is, write a C program to sort a given 1D array using pointer in ascending order. So you are given an array of integers and you have to sort it in ascending order. So like for example, it is 8, 90, 70. I think 8 is the number of elements in the array. Okay, 8 is the number of elements in the array. Then there are these 8 elements: 90, 70, 30, minus 10, minus 40, 20, 100 and 50. These are your numbers in the array. And this is your output, which is the elements in the ascending order: minus 40, minus 10, 20, 30, 50, 70, 90, 100. Now is the question clear? Is this question clear? What are you asked to do? You're given a 1D array of integers and you have to sort them in an ascending order. Now can you tell me how can you do that? Like how will you do that? Have you learned any algorithm to do sorting? Did you learn any algorithm to sort the elements in ascending order? Any answers? Did you learn anything today which can help you to sort the elements in an array? Can you use bubble sort here? So we discussed bubble sort today, and what was it used for? So bubble sort is one of the algorithms which you can use here to sort the elements in ascending order, okay, or descending order, whatever you want to do. Like you can do it the ascending, descending, but one of the sorting algorithms that we discussed today in this tutorial session was bubble sort. So other examples of sorting algorithms, I think you have already learned about in the previous week, was like selection sort, insertion sort, or I think you learned about these two more. Not sure if you learned any other way of sorting or not. Okay. So let's look at the program, because I've already explained bubble sort to you in detail today. So now let's look at the program for bubble sort. Okay, so this is your program for bubble sort, and the first you have declared an array A. A is an array of integers which can have like 100 integers. Okay, then I is an integer, n is an integer. First you are reading the value of n, where n is the number of elements in the array. Okay, and that is your first input value in the 8. So that is your number of elements in the array. So that you are going to scan and store it in n. Okay. Then you are in the next line, you are going to use this value of n to write a for loop. Okay. In the for loop, you are reading the next n values. The next n values are your array elements. So you are going to read them and you are going to store them in the array. Okay. Now A is your array which contains this n elements. Now you have to sort them. So how do you do the sorting? So for sorting, you will do that whatever we learned in the bubble sort, that they can be up to n, like there are up to n passes, and in every pass you go over all the elements in the you go over elements in the array, and you compare them pairwise, like adjacent elements, and you swap if they're not in order. So that's what you're doing here. So the first for loop I is equal to 0, I is less than n minus 1, this is your external pass. Okay, this is your one, like these are your passes of the bubble sort. Then inside the for loop you are here doing that if I is 0, then you will start from j equal to I plus 1, and you are going to compare I and j. Okay, so okay, this doesn't seem to be, I is here, j is moving. Them. Okay, this is not, I'm not sure, this is not bubble sort, this is, I think, selection sort, but I'm not sure which one is this, but this is some algorithm, I think selection sort, if I'm not, one second. Yeah, so this is selection sort. So here, sorry, this is not bubble sort implementation, this is selection sort here. So what is happening here is that you're going to, your first you're going to, here you're looking at the ith element, okay, that is the 0th element, and then you are checking every element in the array from I plus 1 till n, and you are comparing it with the ith element, like the 0th element here, and you compare them, and if you say, okay, if ith element is greater than the jth element, then you just swap them. And this is similar to bubble sort. Here you are actually looking for the small, there you are bubbling up the largest element in the end after every iteration. Here you are finding the smallest element in every iteration and putting it at the right position. So now I'll just quickly explain this on the whiteboard, that what it is doing in terms of, like, we can just look at the pass quickly. Okay, so if this is your array 10, 5, 6 to 13, okay, if this is your array, let's say 43, whatever. So in the first for loop, I is here. Okay, this is your I, which is for the first for loop. This is your I'll use a different color. This is your j here, which is j is initialized to I plus 1, right? Yeah, here I is 0, j is I plus 1. Okay, so what you're doing here is that you're comparing I and j values. So 10 and 5 you compare, and if the jth value is less than the value at ith index, then you will swap. So then the output will become 5, 10, 6 to 43. And this is your inner loop which is working. Okay, so your inner loop, that is the jth index, will be implemented while your ith variable is still pointing at the first position, and j will now point to 6. Then you will compare I and j again, 5 with 6, but 5 is smaller than 6, so you won't do anything. Okay, then your j will be incremented and it will point to 2 now. So then you will compare 2 and 5. Now 2 is smaller than 5, so you're going to move here. You're going to swap So when you swap, this will become 2, 10, 6, 5, 43. Then your j will be incremented and it will come at 43. Now, is 43 less than 2? No. So 43 is not less. So one iteration, then j will be incremented again and it will go out of the like out of bounds. So that's at this time your one inner loop finished, one inner for loop has finished. Okay, now when your inner for loop finishes, then your I will be reset. I will be incremented and now it will point to 10. Okay, this is your second for loop. So I will just that is the second iteration of your for loop. So I will write it here. So 2, 10, 6, 5, 43. I should write them with a little distance in between. So this is this. And this I is incremented. And this is pointing here. This is your I. Now what will be your j? J will again start from I plus 1. So this will be your j. Now after, the thing which we need to note here is that after one iteration of the outer loop, which is the one pass, your smallest element has reached the first position. So the smallest element, which was 2, reached to the first position. Okay, so selection sort, so this is implementation of selection sort, which finds the smallest element in the unsorted array and positions and puts it at the correct position. So 2 is here. Now in the second pass, your second smallest is 5. So 5 should come at position 2. So let's just do one more pass and see how it works, and then we will just quickly look at the code and see whether this syntax, like we'll just look at the code. So then I and j values will be compared and 6 is less than 10, so they will be swapped. Okay, so this will become 2, 6, 10, 5, 43. Now I is here. Okay, I is still here. J will be incremented. Okay, J will be incremented. J will come here. Now I and j will again be compared, and when they are compared, you will see, okay, 6 is greater than 5, so let's swap. So this will be 2, 5, 6, sorry, 2, 5. 10 will remain at its position. Okay, 2, 5, 10, 6, 43. Only these two will be swapped. Others will remain at their position, right? So this. So now you have done this. Then j will be incremented. J will come here while I is still at its position here. Now you compare I with j. 5 with 43, that nothing needs to change here, and then j will be incremented further. It goes out of bound, and that's when inner for loop will terminate. Okay, so then you will again see that after second iteration, 5, which is the next smallest, is at its correct position. So that is, you always look at the unsorted array. Here you looked at this unsorted array, found the smallest element and moved it at correct position. That's what happened. And this is selection sort, and this is an implementation of the selection sort. That is the first for loop. Here you are at position I and you are looking for the number which is the ith smallest number. And how do you do that? You look for all the elements from I plus 1 till n, and you compare that number with the ith number, and if that number is smaller than ith number, then you will swap it. And you do that for all the numbers which are on the right hand side of I. So in that manner you will find the smallest among them and you will have swapped it with I. Then you will increment I, looking for the next smallest number, and then you will find that next smallest number in the list of unsorted elements in the vector. Okay, this is how you will sort the array, and finally you will have a sorted array in ascending order. Okay, and you can just print it here. Print the array basically using this. I hope you understand the pointer arithmetic. If not, just let me know. So you are just doing here pointer arithmetic. That is, A is the array address. Okay. This is used here also. You can write it in another notation as well. Like simply you can just write, you could have written it if A of I is greater than A of j. That will be simpler, but the question specifically asks that using pointers. So since they have asked you to use pointers, so this is how you will write. You will write it as A, which is the base address, plus I, and the value at that address. So this is same as this A of I, A square bracket I. This is same as writing this syntax. Both of them are same. That is value at index I. So is this clear? Is there any question? Is there any question? Okay, so if there is no question, I think we can end the session here. So today we discussed a few like MCQs and then a few programming questions. Okay. Any questions? Any doubts? Okay, I'll stop the recording.